The circle of fifths. Everything you need to know so you don't fail music class in 11 minutes. There are 12 different musical pitches in Western music theory, and each one can be assigned a letter name. Here they are on the piano keyboard. Above or below that, the pattern just repeats. The notes sound basically the same, just higher or lower. In addition to looking at and thinking of the letter names chromatically as they appear on the piano, we can also arrange them in this special pattern called the circle of fifths. It doesn't look like much, but this is an incredibly powerful reference tool with a number of useful properties and patterns. You'll commonly see versions of the circle of fifths with information about major key signatures and relative minor keys. But you can also use the circle to get a better understanding of harmony, intervals, transposition, chord structure, and probably a whole lot more. Honestly, the circle seems to have insights that just keep on giving. It's almost like a reference chart of useful math equations, and the periodic table of elements, and a color wheel, all in one, but musical, like a magical musical device. But to understand how it works, it's helpful to know how it's built. The structure of the circle of fifths is a bit like those drawings of impossible stairs where you keep going up or down, but eventually you'll end up arriving at the same place. But instead of going up or down a stair as you go around, the notes go up a fifth clockwise and down a fifth counterclockwise. And if you keep going, you'll end up where you started. This isn't possible in the physical world, but it is possible in music. Let's see how this plays out on the piano. We'll start on C and go up a perfect fifth, which you could either think of as the fifth note of a major scale or as 7 semitones. If we go up another perfect fifth, we get D, and up a perfect fifth from D is A. Continuing the pattern, the fifth note of A major is E. The fifth note of E major is B. A perfect fifth above B major is F sharp, and 7 semitones more brings us to D flat, followed by A flat, then E flat and B flat, followed by F, and, would you look at that, we're back at C. Keep in mind, what's important is the letter name rather than any specific note in any specific octave. If we wrote out the notes we just looked at on the piano, it would look like this. But there's no reason you can't use a high or low version of a note when it's more convenient. These two versions of the notes from the circle have slightly different shapes, but the note names are the same, and they loop right back to the beginning, just like a circle. Next, this circle that we just made is missing a tiny detail. These three at the bottom actually have two names because each note on the circle of fifths corresponds to a major scale, which has a unique key signature. And according to the rules of major scales, there are 3 with enharmonic equivalents. Those scales can be written in 2 different ways, but they actually sound the same. And when we look at the key signatures for all these scales, we see another interesting property of the circle. Starting at the top of the circle, C major has no sharps or flats. But as we go around the cycle clockwise, we start adding sharps. G major has 1 sharp, D major has 2 sharps, A has 3, E has 4, B has 5, F sharp has 6, and C sharp major has 7 sharps. Going the other way adds flats. The key signature for F major has 1 flat, B flat has 2 flats, E flat has 3, A flat has 4, D flat has 5, G flat has 6, and C flat major has 7 flats. So all the sharp keys are on this side, and the number of sharps increases going clockwise, and all the flat keys are on this side, and the number of flats increase going counterclockwise. And all the ones that have 2 versions are here at the bottom, and the sharp and flat forms overlap perfectly. And since every major key shares a key signature with a relative minor key, you might also see some versions of the circle of fifths with the minor keys aligned with the relative major keys. And keen observers will also see that the order of sharps and flats is right here on the circle, clockwise for sharps and counterclockwise for flats. So it's pretty obvious that the circle of fifths is a useful reference tool since it shows all the major and minor key signatures. But why not just keep all that information in a list or a chart? Why does it have to be a circle, other than the fact that it's kind of neat? The reason for that has to do with all the other patterns that emerge on the circle that we mentioned earlier. Let's start with harmony. Harmony is a complex subject that can be broadly understood as the study of what chords are used in a piece of music and how those chords relate to each other. 3 of the most ubiquitous chords are the ones built on the 1st, 4th, and 5th note of any given key. In C major, that refers to chords built on C, F, and G. They're found in almost every piece of music you could think of. These chords can appear in quite a few different versions, but each one is still based on the same root note of 1, 4, and 5 of C, or C, F, and G. Now, notice that F and G are right beside C on the circle. For any key, the 4 chord is 1 step backwards on the circle, and the 5 chord is 1 step forwards. In E major, the 4 chord is A, and the 5 chord is B. In B flat major, the 4 chord is E flat, and the 5 chord is F. So, in addition to major and minor key signatures, the circle is also a great reference tool to quickly find chords related in any key. And it isn't just for show. You can hear how well these chords fit together. Listen as we move between C and its adjacent chords. We can hear how well they fit together and how much they ground us in C major. Even popping over to the A minor chord works pretty well too. Generally speaking, if you only move one step on the circle, the chords will sound pretty related to each other. Even just a two-step jump can sound a bit surprising compared to the adjacent chords. Each jump will have a unique character that might sound pretty good or pretty odd depending on the context. For the most part, as we move forward in musical history, the more comfortable composers and listeners would have been with larger jumps. Many of these sounds are interesting today, but would have been rare or unheard of at different points in musical history. Moving directly across the circle is a pretty odd sound, but it's possible to prepare the ear for that tonality by approaching one step at a time. Then, if you normalize that key by hanging around it for a while, the original key actually sounds kind of strange. But by moving stepwise, you can head to pretty much any chord you like, even all the way around the circle. And no single chord change sounded particularly strange. And you can certainly do this in either direction for a different flavor. Granted, it's rare to go all the way around the circle in a piece of music, but it's actually quite common while practicing. Many musicians practice chords, scales, and patterns through the entire cycle, like this pattern in C, followed by this pattern in F, then B flat, and so on. And there's utility to practice going in the other direction as well. That way, all the common movements around the circle from any point are familiar on your instrument. Next up is intervals. Think of the circle like a clock. We already know that moving one step clockwise is a perfect fifth up, and one step counterclockwise is a perfect fifth down. Other intervals are reflected clockwise and counterclockwise as well. 2 steps on the circle is either a major second up or down, and 3 steps is a major sixth up or down. Every interval on the circle is reflected by going in the opposite direction. Here's a chart for all the intervals on the circle. Clockwise makes the interval go up, and counterclockwise makes the interval go down. This idea is useful for a couple of reasons. First, you could use this as a calculator to transpose a note or a key. Musicians who play transposing instruments need to do this all the time. For instance, most trumpets and clarinets are in B flat, so they need to play a major second up from concert pitch. Usually they're given music that's been prepared for them, but say they've been asked to play a specific scale, they can just move 2 steps clockwise on the circle. If they're asked to play an E flat concert scale, they simply move 2 steps clockwise and know that they need to play an F major scale. E-flat instruments like alto and baritone saxophone would need to move 3 steps clockwise. And F instruments like horns would need to move just 1 step clockwise. Many musicians will find this a useful tool to transpose anything for their instrument quickly and accurately. The second reason this idea of intervals on the circle of fifths is useful is because it provides a bit of insight into interval inversions and how and why they work. For instance, we know that the major third and minor sixth are inversions of each other. C to E is a major third, and E to C is a minor sixth. They're the same note names but flipped around. If we look at those intervals on the circle, we see that the major third is 4 steps and the minor sixth is 8 steps, and together they close the circle. You'll find that every interval and its inversion will close the circle and add up to 12 steps. Continuing this visualization, we can analyze the structure of chords by looking at how each specific note of a chord falls on the circle for some pretty insightful patterns. This is a major chord. It's just a perfect fifth and a major third played at the same time. The major chord is always in this shape on the circle. You can move the shape anywhere and get a major chord because every major chord is a perfect fifth and a major third from the root. Comparing the shape of the major chord and its parallel minor chord, like C major and C minor, you'll see that the shape is actually a perfect reflection of the major chord on the circle. 2 notes stay the same, C and G, and only one note, the third, changes from E to E flat. Interestingly, even though the major and minor third are right beside each other on the keyboard, they're almost directly across from each other on the circle. This may give some insight into why the 2 chords seem similar, but are so different in sound and function. There are also 4-note versions of these chords, like the major 7th chord, which is 2 perfect fifths between C and G and E and B. And there's the minor 7th chord, which is also 2 perfect fifths between C and G and E flat and B flat. The 2 shapes aren't quite the same perfect reflection as the major and minor triads that we just looked at, but it is pretty close. But probably the most important 4-note chord is the dominant 7th chord. That interval between the 3rd and the 7th directly crossing the circle is known as the tritone, and that's what gives the tension to a dominant chord, which generally wants to resolve to this chord. A closely related chord is the frighteningly named minor 7 flat 5 chord. It's just a reflection of the dominant chord on the circle, but functions similarly because it maintains the same tritone between E and B flat. Yet another reflection of the dominant 7th chord is the equally frighteningly named tritone substitution, which is just another dominant chord a tritone away. Similar to the minor 7 flat 5, the 3rd and 7th remain while the root and 5th change. So the function is the same, but the tonal color is quite different. Here's the sound of a standard cadence. And here it is with a tritone substitution. Some chords have patterns that aren't spaced out at all, and have their notes right beside each other on the circle. A suspended 4 chord looks like this, and a suspended 2 chord is pretty similar but with a different flavor. The 6-9 chord pretty much just takes over one side of the circle entirely. Other chords have notes as far away from each other as possible on the circle. The diminished triad is sort of spooky sounding and makes this shape, and the diminished 7th chord fills in that last side of the circle. Finally, the augmented chord trisects the circle equally, with 3 notes that just can't get any further away from each other. Whether you're using the circle of fifths to learn and remember key signatures in parallel minor, exploring interesting colors and properties of chords, or calculating intervals and transpositions, it's clear that the circle of fifths is an incredibly useful reference and visualization tool that almost every musician can make use of. Remember to like, comment, share, and subscribe, and check the description for links to more videos. Thanks for watching!